Lines are a powerful element in design, and I like to use them wherever I can in my day-to-day work. Drawing them can be easy, but things get a little more complicated if you plan to animate them. You have to decide what kind of animation you wish a spline to have, a deforming motion or a revealing one. Sometimes you wish to have a mix of both, and to make things more difficult, you have to take into account the number of lines that you wish to draw and animate. I've experimented a lot and found some solutions which aren't that straightforward but do the job. This is the first of what I hope to become a series of videos on the subject of drawing and animating lines using Cinema 4D with some Xpresso. I hope to teach you some Xpresso along the way. Today I will show you how to animate the drawing of lines along pre-built splines using thinking particles. Yes, I know it's an old module and has been part of Cinema 4D since, I believe, version 7. I know that X particles are all the rage these days and are fun and easy to use, but I still prefer thinking particles over them because it gives me the freedom to program if I want every aspect of the particles using Xpresso, which I am very passionate about. I'll explain the basic principle first, then build a portable preset, and then use that preset to build something like this piece of animation that I made some time ago. As I said, I'm going to teach you how to draw lines along pre-built splines. So the first step would be to have those pre-built splines. I will simply start and draw some splines with the sketch tool. 1, 2, 3. And then add an Xpresso tag to the spline. A habit that I'm trying to impose myself is to organize my Xpresso nodes into groups. That is for better organization and to be able to understand later on when I open an old project what I've done in the past without too much hassle. So I will begin by creating an empty X group and dive in it using View Full Screen. As I said, I will use thinking particles. So the idea here is to create particles that run along these splines and then use a tracer object to generate the paths those particles are running along. So we will have as many particles as there are spline segments in this spline object. First things first, we will get an object. In this case, Xpresso is giving us the object which the Xpresso tag is attached to, which is the spline. I will get the spline information from this object, feed the spline object into the object input of the spline node. And what I want to get is the number of segments that this spline object has. Now there is a problem that I have found using the spline node. I don't know whether it's a bug or not. And let me show what the problem is. I will get Xpresso pool, get a print to console node. And now I want to connect the segments output to the print to console input. And as we see, the current spline object has 3 segments. But what happens if I now go to Tools, Modes, Points? If I only have one segment, a spline with one segment, sometimes, I don't know why it's not working right now, it was working previously when I was rehearsing to record this tutorial. Sometimes The number of segments that is output from this node when there is only one segment is 0, not 1. I don't know why it's the case, but it happens, I promise you. And to overcome this problem, I have this solution. I compare the number of segments using a logic equal node, and I compare this number with 0. So if the number of segments is 0, then the equal node will output true, and the value for true is this second one. I will output 1. And if the value of segments is not 0, then I will output the actual number of segments. Let me now test what I have done. I'll go to print to console and output this value. It is still 1. And if I now add other segments to this spline using the sketch tool, you see the information down here in the console updated in real time. So now I have 3 segments, 4 segments, and so on. Okay, let's go on. Now, the number of segments of the spline will drive the number of particles that will be born. And so the node I will use to generate those particles is found down here at the thinking particle group of nodes, generator pborn. Let's open the properties for this node. First of all, I want the birth type to be count. I want to drive the count number by the number of segments, so I will select the output of this condition node to the count input. I want another input this time for the life property for the particles, and momentarily I will drive this life value with a constant. Later on we'll build some custom user data, so I will drive life with this constant, and let's say for the moment we want this life to be for 1 second, but I'm used to think of animation in terms of frames, not seconds, so I want to convert this value into frames, and the way to do that is to get a time node. Instead of time in seconds, I want to output the frames per second. And I will divide my frame number by frames per second for this particular project, divide, and output the time in seconds. And this technique now allows me to input the life parameter in frames, which is 25 frames, and this calculation gives me the output in seconds, which is what the pborn accepts. And now that I have these particles born, I want to set them up so that they are born at the beginning of each segment of the spline. To do that, I will need to get the spline information out of our object. Again, use the spline node. The segment input will be a particle birth number. The offset for the spline will be set to 0 because I want each particle to be born at the beginning of the spline, and this node will give me the position at which each particle should be born. I will use a pSetData node to set the position of each particle at the moment it is born. I'll feed this particle birth to the particle input of the pset data and the position to the position input. Let's check what we have done. So, as you see, each particle gets born at the start of each of the segments of the spline we are referencing. So far, so good. We will come back later to this group of nodes, but for now, let's go on with the animation part. Let's create another empty group. Let's rename these for better organization. The first group of nodes will be responsible for giving birth to particles, so I will rename it particle birth. And the second group will be responsible for the animation of the particles along the spline. Let's dive into this group, full screen. These operations will be calculated for each particle. So we create a loop that will go over each particle and repeat the same operation. To get a loop, we use repeat pass node. Let's show the names. By default, thinking particle nodes are not shown the appropriate port name. So what we want to drive is the particle position. They are going to be moving along each segment of the spline. So we again need to get the spline information. I already showed you twice how to do that. We take an object, then a spline node, feed the object into the spline, and this time we take the particle number. This actually gives us the number for each particle that is being born. Actually, that is its index number, and I want to feed this index number into the segment. That is right. And the offset will be driven by the life value for each particle. So I want to get that information with pGetData node. I want for each particle to get both age and life data. Now the difference between age and life is that life is the total amount of frames that a particle will be allowed to live, and age is the current state during that lifetime that the particle is right now. So let's say a particle has a value of life of 25 frames, and age is the state of the particle on a particular time during that journey from 0 to 25. I hope I made myself clear of that. So I will now normalize age and life, and I will do that using a division operation. I will divide age by life, change the function from add, which is the default, to divide, and that will give me a value from 0 to 1 from each particle during its lifetime. And I will feed this result to the offset value for each spline. Now I will take the position that this operation gives us and feed it to the position of each particle. It seems that I'm repeating myself, but let me make myself clear and tell you that the operations that we are now calculating in this second group of nodes are calculations that are done on each frame of the animation. And the calculations that we did previously in the previous group are done only once when the particles are born. So these operations are responsible for the animation of the particles. Let me now get a particle set data, feed the particle index number to this node, and get the position from the spline to the position of this pset data node. Let's check what I've done so far. Okay. Now the particles are actually moving along the splines, but only the first three ones are moving along the appropriate spline, and the rest of them are sliding along the last segment. And that is because whenever the number of particles exceeds the number of segments, then these new particles with index numbers greater than the number of segments only slide along the last one. To get rid of that problem, we will go back to our first group of nodes. Let me get out of this group of nodes, get into the first one. And now I will do a modulo operation on the particles that are given birth and make sure that the index number of the particles does not overcome the number of segments. So I will use a math node with the operation set to modulo, and the number I want to use as a modulo is this number here. Is the number of segments, which is here to be precise, and I want to divide this, but as you see, the line connecting these two ports is gray, which means this operation cannot be performed because the input port of the modulo needs a real number and the output port of the p-born node is of type thinking particle. That problem is easily overcome by adapting this value using a universal adapter node. Change the data type from real to integer, because the index of each particle in fact is an integer number. And now I will feed this modulo operation result to the number of segments instead of the actual particle birth value, and that takes care only for the birth part of the particles. We have to repeat this operation on the animation part. As I said, I will take again universal adapter node, change its data type to integer, and divide the index of each particle by the number of segments using a modulo operation. And the number of segments, as I said, I will get by using the object spline segments. As I said, to overcome the problem that arises in case the number of segments outputs 0 instead of 1 when we only have one segment per spline, I will do the same operation I did previously by comparing this segment number to 0. And if it is equal to 0, it will output 1. And in any other case, it will output the actual segment number. So now I want to feed this into the modulo input node, and the result of this modulo I will feed to the segment number. So, as you see now, each particle that is given birth is now sliding along its appropriate segment of the spline. To make it more easily visible, I will go to thinking particle settings and change the view type from ticks, let's say, to box. Okay, and the next steps will be some optimizations and automations to this setup. Apologies for the quality of audio recording. I forgot and left open both microphones, my main one and the one attached to my earphones. I hope the audio quality is better now. Now it's time to optimize our setup so that it's easily portable to other projects. A good idea would be to have the Xpresso tag attached not to the spline but to a tracer generator. And I will adapt my setup accordingly in a short bit. Let's add some custom user data to our Xpresso tag. The first one will be the spline that we'll add as a guide to our particles. The data type for this custom user data would be a link. The second one will be the number of particles per segment. Its data type should be integer. There won't be any limit, and the default value will be 1. Another user data should be the number of frames that a particle will live. I'll call it life. It will also be an integer number, and the default value, let's say 25 frames. Life variation. This time the data type will be float slider, and the default value to 0%. That's it for now. Maybe we can add other custom data later. And now let's adjust our setup. First we'll go to the particle birth node group, and instead of this node that previously represented the spline object, we will now drag and drop the Xpresso tag, and the data we will get out of it will be spline. Don't worry about these errors that Xpresso is giving us. We used another instance of the spline object, and we will now again replace it by our user data, spline. This constant that we previously added for our lifetime will be replaced by our life user data. Again, let's add some life variation to our particles. Maybe we'll not use that part, but let's make it available. And now for the particle per segment part, we are currently giving birth to as many particles as there are segments, but it would be nice to have some multiple of that number available if we want to. So instead of count, I will multiply this by this number, particle per segment. Let's change the operation mode to multiply and feed this number to the count number of the p-born node. It seems I've finished in this Xpresso node group. Let's go to the next one. And this is why I'm trying to organize myself better by using Xpresso node groups. I can easily come in and make changes to the node groups and better understand what I am doing with logic. Now I should replace this object node with the one that comes from the spline port. Let's multiply again this number with the number of particles per segment. Replace it here. Alright, here's another instance of the spline object that should be replaced with the one coming from our spline field. I have created a field to input my spline, but I left it empty. Let's now see what I have done. Now everything's working as it should. Make the tracer trace particles. At the moment it's tracing nothing. I will trace this particle group. The limit should be set to from and it should be made customizable. Let me have 25 frames. Maybe 25 frames is a bit too long. 10 frames. Now look at this cool setup we have created. We can feed now to this setup any spline that we wish, and that is what I'm going to do next. Now it's time to get this setup to good use. I will show you how I did the piece that you saw in the beginning of this video. I started by drawing this figure, which is a double-headed eagle. It is present in our national flag. Now it is a matter of just dragging and dropping this spline, making it the guide for our particles. And to add some variations to this otherwise very regular spline, I used another trick. I generated a hair object, made it generate hairs not in this manner but spline guides, so it's only one hair generated per spline. Go to the hair tab and change the root mode from auto to as guides. Add clones. Add a hair material and play with the offset value for each clone. Okay. Maybe you cannot see, but now if I convert this hair object and make it generate splines, you can see what kind of variation that hair tag added to our initial spline. Now I can feed this hair object into my guide spline and have a look. Don't worry, this all happened because hair have dynamics automatically enabled. Here it is. Well, this is just one example of how you can use this technique. I hope in another video I will show you another technique that I have now made my own. It also involves Xpresso and splines, but it's not dependent on particles. Until then, I hope you enjoyed this video. I would like to hear your comments, your thoughts about this technique, and please don't hesitate to share the knowledge. You'll hear from me soon. Bye.